Okay, where do you want me to start?
13
Which
through
one?
17.
Somebody said 13 though?
13 through 17.
Okay, what?
13 through 17.
13 through 17. What do you know? All the word problems, huh?
I hate word problems. I can't read.
They hate you. All right, it says the key, of course, always for these is to draw a picture. Okay. It says a lighthouse is east of a sailboat, so let's go lighthouse and let's go sailboat. This seems like one of the ones that somebody presented to class the other day. The sailboat's dock is 30 kilometers north of the lighthouse. So 30 kilometers north here is the dock, and let's label that. 30 kilometers. Okay, so far so good. The captain measures the angle between the lighthouse and the dock and finds it to be 35 degrees. So captain looks at the from the sailboat to those two things and finds out that this angle is 35 degrees. Where exactly is the captain trying to get? Do you think? Yeah, they're trying to get to the dock, so he wants to travel, he or she wants to travel along the hypotenuse. So the question is, how far a distance is that? Okay? So yeah, since we know the opposite side, bless you, and we're trying to find the hypotenuse, that means that we're using sine. So the sine of 35 is equal to the opposite side, which is 30, over the hypotenuse, which is, so how do you solve that?
30 times.
So 30 divided by the sine of 35. We do the old switcheroo with these two things and rewrite it as x equals 30 over sine of 35 degrees. Type that into senior calculator and you get about 52 kilometers if you have done it correctly. Okay, make sense? It's all about the picture. Okay? Once I get that picture up there, I'm pretty sure you guys can all look at that and go, okay, I know I've got a right triangle and the opposite of my hypotenuse and all that kind of stuff. So draw a picture. All right, number 14. An air traffic controller must calculate the angle of descent for an incoming jet. The crew reports that their land distance is 44 kilometers from the base of the control tower. So that's their distance along the ground. That is 44 kilometers from the base of the tower. Okay? And we also know that the plane is flying at an altitude of 5.6 kilometers. So if this is my airplane here, then we know that this is, you screwed up my airplane, man. Yeah. When you need it by? End of June?
Okay, well, Mike.
Tomorrow.
You got any money on you?
ASAP.
You got any money on you?
A truck?
I don't know, you know.
Got an eraser with some profane words on it.
Not gonna
Joseph
cut.
Choi.
It's not going to grease the wheels at all. No, it's something better than that. Okay.
Do you got any utensils?
No, I got lots of writing utensils.
I have a question.
Okay?
Pair of kicks?
Fresh pair of kids.
No,
We
they
don't
don't
have this
fit.
school on the 28th, okay, that was my question.
Okay, great question. All right, so this is the picture. Okay? So they're 5.6 kilometers above the ground. Their land distance from the tower, the distance on the ground is 44 kilometers. What are we trying to find in this situation? The angle of descent, yeah, which is a little bit confusing. That is not going to be this angle right here. It's actually going to be this angle right here. Okay, so we need to figure out how far, how far down they need to go. But the way we can do it is we can figure this one out, and then what's the relationship between this blue angle and this yellow angle? They're corresponding, or they're not corresponding, they're complementary is what you're thinking of, starts with a C. Okay, so let's do that. So what trigonometric ratio can I use to figure out that angle in the corner? Tangent. So the tangent of that angle, let's just call it angle A, funsies, is equal to the length of the opposite side, which in this case is 44, divided by the length of the adjacent side, which is 5.6. And then since we're trying to find the angle, what do we do? Right, the opposite, the inverse tangent, the arctangent, whatever you want to call it. So you go second tangent, 44 divided by 5.6, and the survey says 7 point what? 7.3. Great. Okay, and that's the answer in the book, so I guess that is the answer that they're looking for, is 7.3 degrees. Okay, so we're all right. Okay, 15. Now this one has a picture right in there already, so you shouldn't have any excuses for not getting this one right. Figuring it out. So you have a house, and I'm only going to draw the one side, because that's all we really care about. We know that the angle that the roof makes is 36 degrees. Okay? And then we know that the entire base along here is how much? 32, so that means that this distance will be 16. And we are trying to figure out how long that this truss has to be, recognizing that it's got to hang off an extra 2 feet. Because, okay, so how long, or each rafter, I guess is what we're doing. So what am I looking for here? Do I want to do cosine yet? Because I'm trying to find the hypotenuse. I know this side, which is the adjacent side. So the cosine of 36 degrees is the adjacent side divided by the hypotenuse. What do I do to solve this? Multiply or divide? Divide. Good. Switch those around. So x equals 16 divided by cosine of 36. What do you get for x? Not what is the final answer. What do you get for x? 15.7? 19.7? They rounded it up to 20. So you want that rafter to be 20 feet, and then we have to add on that 2-foot piece there, so it's going to be altogether 23 feet. Okay? All right, number 16. Okay, during a flood relief effort, a Coast Guard patrol boat spots a helicopter dropping a package near the Florida shoreline. Officer Duncan measures the angle of elevation till the helicopter to be 15 degrees. Thank you for that. So this is 15 degrees above the horizontal. And the distance to the helicopter is 6,800 meters. And then the package, of course, is going to come straight down and land right here. How far is it from the patrol boat to where the package will land?
What is that, a helicopter?
That's like this little landing things that they land on. Well, it's a special emergency storm helicopter that has super long legs in case it needs to
Land in water?
land in water. Okay, so the question is, what's x here? What am I going to use? cosine once again, because I want the adjacent, I know the hypotenuse. So cosine of 15 degrees is equal to, this time the adjacent side is the variable, so it goes on top. So do I multiply or divide to solve this? Multiply. Why? Oh, I'm solving for x, and so since it's x divided by 6,800, to get rid of that 6,800 and get the x all by itself, I'm going to multiply both sides by 6,800. Okay?
6,568.
Is that what you got?
I got it.
6,568. And that's what they got too. Okay, and then the last one is number 17, Amelia. Yeah, Richard said 13 through 17, and then we're done. At an air show, Amelia sees a jet heading south away from her at a 42-degree angle of elevation. So I'm having kind of a hard time, right? So off it goes, away from her, 42-degree angle of elevation. Right? 20 seconds later, the jet is still moving away from her, heading south at a 15-degree angle of elevation. So this is a little tricky. Gotta fix my drawing here. So it goes at this 42-degree angle of elevation for only 20 seconds. And then it goes from there at less of an angle. So it gets up in the air and then kind of starts to level out a little bit. And so we need to know that this angle right here is 15 degrees. Okay? Okay, if the jet's elevation is constantly 6.3 kilometers, I don't get it. What does that mean? Isn't it going up? Okay, so that was an epic fail. Okay, so here's what's happening, Mackenzie said. The jet is flying at a constant angle of elevation the whole time. Okay? And Amelia, the mighty duck man. Oh yeah, that's Amelia. You guys have seen, what's the one, the Eyes of Roxbury? You guys seen that one?
Yeah.
And who said the phone? Emilio, the mighty duck. No?
Oh, no. Too soon? No.
Okay, we'll YouTube it up in a minute. Okay, so this is what your vision is, Mackenzie? So the first time she looks at the plane, it's right here. Okay. I don't know, man. It's in my bones. What can I say?
It's in my phone.
We are working on it today. And this angle right here is 42 degrees. All right. Then 20 seconds later, so it's gone. We don't know how far, but 20 seconds later, she sees the plane again, and now the plane, when she goes to look at it, is at an angle of elevation of, is it 17 degrees?
Yeah.
What? 15? Okay. All right, so that's what our picture looks like. I screwed that up. All right, and then it says the jet's elevation is constantly 6.3 kilometers. How fast is it flying in kilometers per hour? All right, let's go back to you, Mackenzie. What do you got? Okay, so the first thing that she is doing is she's going to look at this little triangle right here and say the tangent of 42, since this is 6.3, you're going to find this distance right here. Okay, I'm going to trust you. So the tangent of 42 degrees equals 6.3 over x, right? Okay, so flip those around. X equals 6.3 divided by the tangent of 42. What is 6.3 divided by the tangent of 42?
6.99.
6.99. Okay, so what you got too? Okay, so that comes out to be about 7 kilometers. All right, what are you going to do with that? Okay, so now she's going to look at the whole bigger triangle here. So this whole thing right there, and find this entire distance, which we'll call just for funsies y. So give me an equation that I can use to find out what y is.
6.3.
Tangent of 15 degrees equals, thank you, 6.3 divided by y. So again, flip those around and say y equals 6.3 divided by the tangent of 15 degrees. And what you get from that? 183.5? 123.5? 23.5. Okay. Having an off day today. It's too nice outside for anyone to be thinking about now. Okay, so what did you do with those two numbers? Okay, so if you subtract 7 from that, then that gives you this distance right here, which means the plane in that 20 seconds traveled 14.5? No, totally wrong. 16.5. 16.5 kilometers. Okay, so now we're all set because you know it went 16.5 kilometers in 20 seconds. Let's take this step by step. If it took 20 seconds for it to go that far, how far would it go in a minute? So if you go 16.5 times 3, then that means it would have gone 49.5 kilometers in 1 minute. How do you take that and figure out how fast it's going in kilometers per hour? Times it by 60. And hopefully, if you do that, you get about 2973. 2970? Works for me. 2,970 kilometers per hour. So that airplane is going really fast. Why?
Just shows how to do 19. I come up with 11.
19, you just do the law of sine. Sine of 53 over 25 equals sine of 76 over W.
Really?
Okay? Yeah. 23. 22. Yeah, you do have to do that square thing. Yes. Okay, so last couple ones here. If you know all 3 sides of the triangle and you're trying to find missing angle, yeah.
What we start that one for 20? You use the law of cosine. Find the angle. You use the law of cosine.
No. Sine of 50 over 29 equals sine of A over 37. Okay, if you have an angle on the side opposite it, you usually are going to go with the law of sine.
Okay, how do you know when you use cosine?
When you don't, like this one right here, I've got no angles opposite these sides.
So, and then like if they give you an angle.
If they told me what this one was, then I could go a law of sines, because I could go sine of this over that equals sine of this over that and figure out everything I need to know.
And then we give you 2 sides and then an
And
angle.
then the one in between it,
Yeah.
again, screwed me over because I didn't do the one opposite yet. So if you have the side opposite the angle, it's sines. If you don't, it's cosines.
Alright.
Alright? Okay, so this one we need to find angle B. So this is that crazy one where the cosine of angle B is going to equal, what number do I do first?
27.
27. Always start with the side opposite the angle that you want. And then these, the order doesn't matter. Minus 34 squared minus 27 squared divided by negative 2 times 27 times 34. Okay? Now, I had some people in my 6th period class that were struggling with this because it's easy to have the calculator kind of tell you the wrong answer. If you are one of those people, my suggestion to you is to do the top first. Okay? So right now, somebody figure out what's 27 squared minus 34 squared minus 27 squared. Tell me what you get.
Oh.
Negative what? I heard the 6 and the 1,000. 1,000 what? 156. Okay, so this top part comes out to be negative 1,156. Now do the bottom part. Now go negative 2 times 27 times 34. You got it? Okay, what you got? 1,836. Okay, now to find the angle, we have to go the inverse cosine of negative 1156 divided by negative 1836. Okay? So if you're struggling with doing that whole fraction thing all in one piece, do the top, and then do the bottom, and then you're good to go from there. Okay, what do you get for the angle? 51 degrees. Stop bears. You can go outside today, yeah.
And you can't get back in.
No, you can go outside today. Then you can come back in if you want. You just have to wait till 2:50 to do it. You can do whatever you want. It's horrible. Sarcasm. Of course I care what you do.
Yeah, it is. Are you sick? You have to work.
Okay, last one, 23. Have to find the area of this what? Not trapezoid. Rhombus, good. It's a quadrilateral, but since all of the sides are congruent, it's actually a rhombus. So there's a couple of ways we can do it. We can figure out the areas of the individual triangles and add them up. Or we could remember our very simple formula for the area of a rhombus. Does anyone remember that? Neither. All right. So we better figure out the area of the triangles then, huh? Yes. What? Something in there about, okay. That looks more like height anyway. Okay, so we better just figure out the area of the triangles and add them together, huh? Well, since I have an isosceles triangle right here, and this angle is 48 degrees, we can figure out what these two angles are. What are they? 66 each, because they have to add up to 132. Okay? So now, like I was talking to Richard about, since I know the side opposite this angle, to find this side here, I'm going to use the law of sine, because that's way easier than the law of cosine. So I go sine of 48 degrees divided by 26 equals the sine of 66 degrees divided by x. Okay? Somebody cross multiply and divide those for me and tell me what you get for x. 32? Yes? Okay, so if this is 32, then this is also 32, right? And then how do I find the area of this triangle right there if I know both of those sides are 32? Yeah. How do I find the area of that triangle there if I know both of those sides? We had a little formula that used sine. That's handy.
Is it 1/2 times,
It's 1/2,
half times A times B times sine C?
perfect, 1/2 AB sine of C. Okay? And what had to be true about that angle in order to use this formula? Had to be in the middle, so which angle do you want to use? So you're going to use 48 as your middle angle, and these two sides as the ones around it?
Yep.
Okay? So we're going to go 1/2 A times B times the sine of 48. But then once we get that answer, what are we going to do with that? No? Double it, yeah, because there's two triangles that look just like that. So if I times that by 2, the 2 and the 1/2 will cancel out. So I really just need to go 32 times 32 times the sine of 48. And if I do that, I get 380.5.
And you double it equals 7.
Did you do the half thing?
Yeah. So 5 times 30.
760. Okay? Okay, why don't you send those forward, please?
Can we have class outside?
Nope.